Hello, so we're going to do a little bit about atomic theory today. And as you can see, the image of the atom has changed over the years. Okay, here is the first ever model of the atom. It was very plain. It was just a sphere. Then as we learned more and more about it through experimentation, the picture of the atom started to come together. And this is what we know of the atom today. It has electron clouds, but we'll get to that in a little bit. Why won't it? Okay. So first off, we have Democritus, 400 BC. He didn't really have any model of the atom. He just came up with the idea first that if you tear something in half enough times, eventually you're going to get to a piece that cannot be torn anymore. That piece would be the smallest particle that is possible, that is in existence. And he coined the term atomos. Then 1808. So you see we went from BC all the way to 1808. We have Dalton. Dalton's atomic theory composed of 5 postulates. And it's very, very important that you know his postulates. Number 1, all matter is composed of extremely small particles called atoms. Okay, first and foremost, they are called atoms. Number 2, atoms of a given element are identical in size, mass, and other properties. That means that every single atom of hydrogen is identical to each other. Every single atom of oxygen is identical to each other. Every single atom of carbon is identical to each other, and so on and so forth. Number 3, different elements differ in size, mass, and other properties. What that means, an atom of helium and an atom of carbon, they're going to be different sizes than each other. Okay, carbon's going to be bigger. All elements, all atoms of all elements are not the same size. Some atoms are bigger, some atoms are smaller. That's what his third postulate meant. His fourth postulate, atoms cannot be subdivided, created, or destroyed. Today, we know that his fourth postulate is not true. We can split an atom. And then the fifth postulate, atoms of different elements combine in simple whole number ratios to form chemical compounds. In other words, when atoms combine to make compounds, the whole atom bonds to another whole atom. Okay, you don't get half an atom combining with another half an atom. It's a whole atom or nothing, whole number ratios. And Dalton's model, like I said earlier, just a sphere, very simple, nothing really to it. Then we have Thomson's model. Okay, Thomson added on to Dalton's model. He added the electrons. Okay, that's what these little red things are. He discovered electrons. Atoms are made of positive stuff. So the yellow represents all the positive stuff that's inside the atoms, and he had the negatively charged electrons floating around. His model was called the plum pudding model because that's basically what it looked like. It looks like plum pudding. Here's Thomson's experiment. Here's how he set it up. You have a vacuum sealed tube. You have 2 metal discs, negatively charged on one end, positively charged on another end. And then he sent an electric current through it. Okay? Now, the first time he did this, the beam went straight across. And then something happened though once he flipped on this voltage source and he charged up these plates. Something happened. Boom, the beam curved. It curved towards the positively charged source. So, claim, electrons are negatively charged. Evidence, the beam moved towards the positive charge. Reasoning, like charges repel. So if this beam was negatively charged, it is going to be attracted to the positive charge. And that is how Thomson concluded that the atom contained negatively charged particles called electrons. He later discovered the proton, and then Chadwick later on discovered the neutron. So that is all we have for today, just Democritus, Dalton, and Thomson. So currently we are 200 years more or less in the past as far as the atomic model goes, and there is a lot more to be learned and understood before we get to the current model of the atom. So I will see you all next time. Bye.